Hello, this is a presentation for Group 1. This is for Lab 1, Intro to MATLAB and Arduino. This lab is an introduction to Arduino programming using MATLAB to control an LED and collect data using a photodetector. This lab aims to explore the relationship between the brightness of an LED and the voltage output from a photodetector. Let's start with some basic concepts. So Arduino is a versatile open-source microcontroller platform often used in electronics projects, while MATLAB is a powerful software for data analysis and visualization. By combining these tools, we will control the brightness of an LED using Arduino and plot the voltage readings from the photodetector in MATLAB. We will also demonstrate how these tools can be practically applied in biomedical engineering, where data acquisition and control systems are critical. First, we connected an Arduino breadboard and integrated it with MATLAB by downloading the MATLAB support page from Arduino hardware. This allowed us to control the LED and make it blink in Morse code. The first part of the project involved programming the Arduino to blink the letter O in Morse code, corresponding to our group number, which is 1. We used an 1 kilo ohm resistor and connected it to the anode of the LED, with the cathode connected to the ground. After running our code, we saw the LED blink in a pattern from the letter O. Okay, those 3 blinks represent the letter O in Morse code, which will be 3 dashes, so that will be the light blinking 3 times. This is a more panoramic view of the previous video where it shows our MATLAB code running and our light blinking 3 times. In the second part of this lab, we introduced a potentiometer to regulate the LED's brightness and a photoresistor to collect corresponding voltage readings. As the LED brightness increased or decreased, the photodetector measured the changes, and we plotted these fluctuations using MATLAB to visualize the relationship between brightness and voltage. As we can see in the video, as we rotated the potentiometer clockwise, the LED brightness increased, and counterclockwise, it dimmed. We repeated this a couple times just to have different readings to add to our data and have a plot for MATLAB. Moving on to the result of the experiment, for the first part, we successfully programmed the Arduino to blink an LED in Morse code, representing the letter O. The resistor connected to the LED helped control the current and prevent damage to the LED. In the second part, we focused on measuring the changes in LED brightness as controlled by the potentiometer. As we rotated the potentiometer clockwise, the LED's brightness increased, and counterclockwise, it dimmed. The photodetector then collected voltage readings corresponding to the LED brightness, which we plotted in MATLAB, and the resulting graph demonstrated a clear correlation between the brightness and the detected voltage, as we can observe in this image. In conclusion, this lab demonstrated how MATLAB and Arduino can be integrated to control hardware and collect data for analysis. By adjusting the LED brightness and collecting corresponding voltage readings From the photodetector, we were able to visualize the relationship between light intensity and voltage. This experiment provided insight into how basic components like LEDs and photodetectors, combined with programming platforms like MATLAB and Arduino, can be used to model and analyze real-world biomedical systems, such as light-based medical sensors. That will be the end of our presentation. Thank you for watching, and we hope that this presentation provided a helpful introduction using MATLAB and Arduino in biomedical engineering projects. Thank you.